contrast to fission bombs, which are limited in their explosive power due to criticality danger, premature nuclear chain reaction caused by too large amounts of pre-assembled fissile fuel. The largest nuclear weapon ever detonated, the Tsar Bomba of the USSR, which released an energy equivalent of over 50 megatons of TNT, 200 mpj, was a three-stage weapon. Most thermonuclear weapons are considerably smaller than this, due to practical constraints from missile warhead space and weight requirements. In the early 1950s, the Livermore Laboratory in the United States had plans for the testing of two massive bombs, Gnomon and Sundial, 1 gigaton of TNT and 10 gigatons of TNT, respectively. Fusion reactions do not create fission products, and thus contribute far less to the creation of nuclear fallout than fission reactions. But because all thermonuclear weapons contain at least one fission stage, and many high-yield thermonuclear devices have a final fission stage, thermonuclear weapons can generate at least as much nuclear fallout as fission-only weapons. Furthermore, high-yield thermonuclear explosions, most dangerously ground bursts, have the force to lift radioactive debris upwards past the tropopause into the stratosphere, where the calm, non-turbulent winds permit the debris to travel great distances from the burst, eventually settling and unpredictably contaminating areas far removed from the target of the explosion. Other types. There are other types of nuclear weapons as well. For example, a boosted fission weapon is a fission bomb that increases its explosive yield through a small number of fusion reactions, but it is not a fusion bomb. In the boosted bomb, the neutrons produced by the fusion reactions serve primarily to increase the efficiency of the fission bomb. There are two types of boosted fission bomb: internally boosted, in which a deuterium-tritium mixture is injected into the bomb core, and externally boosted, in which concentric shells of lithium deuteride and depleted uranium are layered on the outside of the fission bomb core. The external method of boosting enabled the USSR to field the first partially thermonuclear weapons, but it is now obsolete because it demands a spherical bomb geometry, which was adequate during the 1950s arms race, when bomber aircraft were the only available delivery vehicles. The detonation of any nuclear weapon is accompanied by a blast of neutron radiation. Surrounding a nuclear weapon with suitable materials, such as cobalt or gold, creates a weapon known as a salted bomb. This device can produce exceptionally large quantities of long-lived radioactive contamination. It has been conjectured that such a device could serve as a doomsday weapon, because such a large quantity of radioactivities with half-lives of decades lifted into the stratosphere where winds would distribute it around the globe would make all life on the planet extinct. In connection with the Strategic Defense Initiative, research into the nuclear pump laser was conducted under the DoD program Project Excalibur, but this did not result in a working weapon. The concept involves the tapping of the energy of an exploding nuclear bomb to power a single-shot laser that is directed at a distant target. During the Starfish Prime high-altitude nuclear test in 1962, an unexpected effect was produced, which is called a nuclear electromagnetic pulse. This is an intense flash of electromagnetic energy produced by a rain of high-energy electrons, which in turn are produced by a nuclear bomb's gamma rays. This flash of energy